look at our equation, a system of equation. Let's see how the system of equation do look like. Let's see if these ones are right. A11 x1 A1n xn is equal to y1. AM1 x1 AMN xn is equal to ym. This is the sets of the equation that we have. So it means that we can write it as and let's assume that n is greater than n. M is greater than n. What does it mean, m is greater than n? This means three things. One, number of rows are more than number of columns. This means that the number of equations are more than the number of unknowns. And for instance, again, this means that the system is over determined. In such a case, we can use our hero, hero called pseudo-inverse. In such a case, we can use pseudo-inverse where a plus a pseudo-inverse multiplied by a is equal to I. But a plus is not I mean, generally speaking. Unless it has the usual inverse. How come that in such a system A might have the usual inverse? In other words, under what condition A plus is actually A inverse? If some of the rows are redundant and we can just simply ignore them, like they are linear depending on the other ones. Then we can say that A inverse y is equal to A inverse A x It's actually approximately, which results to x is approximately a plus y. A plus is actually calculated by solving least square problem or optimization. In other words, it's an approximation. Because it's an approximation, we use this is approximately equal. However, in this course or in many computer science applications, we strongly use the equality and we go ahead. We will talk about different form of calculating pseudo inverse. However, it is good to know more Penrose pseudo inverse is calculated using this formula, using A plus is A transpose A inverse multiplied by A transpose. We know that this is definitely square matrix. MATLAB, as I said, use the comment p in order to calculate it, and in order to calculate it, MATLAB does not use the least square problem. It uses singular value decomposition, which we will talk about the singular value decomposition in the next chapter. But it's more complicated, but it's much more accurate. Now, I solved a numerical example. The numbers all have been calculated by MATLAB simply in order to give you an idea how the things looks like. Okay? And the example is that I give a numerical number for this formula. So to see how to calculate the A plus. Given A is this matrix 1, 5, 11, 3, 7, 13, then A transpose A means the transpose of this one multiplied by itself. It will be, what will be the size of the matrix? This is 3 by 2. The transpose will be 2 by 3, so if you multiply it will be a 2 by 2 matrix. And if you calculate it, you get 147, 181, 181, 227, whose determinant is equal to 608. Then finding its inverse by using MATLAB, the inverse is 0.3734 minus 0.2977 minus 0.2977 0.2418, and A plus, which was A transpose A inverse multiplied by A transpose, means that multiply this one by A transpose. Now if I do it, what will be the size? This is 2 by 2, this is 2 by 3, so the result is
2 by 3.
2 by 3. So the A plus will be 2 by 3, which numbers are minus 0.5197, minus 0.2171, 0.2368, 0.4276, 0.2039, minus 0.1316. And if you calculate A plus A, you will see that we will get 1001. Can you tell me that if A plus is equal to A plus A for this example? In general, they are not, but I mean, we can come with examples with it is. But in this example, do you think that they are the same? If yes, show me. If no, tell me why. We know that the size of this multiplication is 2 by 2, the size of this multiplication is 3 by 3. So indeed, they are not the same because size-wise they are not matching. Now, usually we show this one to be I2, and the index for I indicates what is the size of the matrix. Okay, finish it, then I can continue with this example of one more thing, so we can see some numerical numbers. Assume this matrix A was from this sets of equation, this systems of equation, x1 plus 3x2 is equal to 5x1 plus 7x2 is equal to 11x1 plus 13x2 is equal to, and are 17, 19, 23. Okay? So we had ax is equal to y. Then in order to find the pseudo-inverse, we said what we are doing is this. We say that a plus ax is equal to a plus y. This was I, so x is roughly a plus y. A plus, we just calculated it. Y is 17, 19, and 23. And if you multiply, we will get this. That x1 is approximately minus 7.5132. And x2 is 8.1184. Let's check it. How do we check it? How do we check the answers? We substitute them into the equations. And we had 3 equations and we substitute them back in there. And I erase this line also, we already have it. And we get this. Minus 7.51 plus 3.812, 5 multiplied by minus 7.51 plus 7 multiplied by 8.12, 11 multiplied by minus 7.51 plus 13 multiplied by 8.12, which we are getting 16.84. 19.26, 22.89, which is approximately 17, approximately 19, approximately 23. As you see, we are not getting the answers. I mean y's, which we were looking for. So, what is going on? What is going on? Anyone has any clue what is going on? Can you, Ike, let's just start from you. You're the first victim. Can you tell me what is the interpretation of this set of equation? And keep this one in your mind. In the real life, you wanted to discriminate your pattern. This is the reality that happens. In the algebra books, undergraduate, this never happens. So that's why that we are studying, because in the reality it happens a lot. But the question is that, what is going on? Can you interpret it to me like, what is this representation? And what these sets of equations represent? Why we are getting an approximate number? Actually, when we have a set of equation, Hassan, when we have a set of equation and we are solving it, what do we get? What do we, I mean, you get that x1 is this, x2 is this, x3 is this. I mean, we calculate the values of x, right? But what does these x values represent, Dana? I mean, you solve it and you get one answer, but what does this answer represent? Ike? What does this answer represent? You have a system of equation, you know, undergraduate math, what was it? Math 131, linear algebra in undergraduate. So the question is that they give you a system of equation, you were using the Gauss, Jordan, lots of other methods, you were solving it, and you came to the value that x1 is equal to 2, x2 is equal to 5. What does this number represent? When you solve a system of equation, what does it represent? Hassan?
Intersection.
Intersection point, excellent. I have two equations, I solve it, and we said that if there is no answer, it means they are parallel. If there were infinity many answers, it means they were on top of each other. And if you have a unique answer, it means that they are intersecting. Now the question is this. Why do I have the three different answers? I mean, x1 and x2, I find it. First of all, why they are approximate, not exact? And second of all, why we are not getting the same value? So what is going on? What is your feeling? Knowing that when we had the two equations, we were solving it, we were getting one unique answer, it means that they were intersecting, and we had this one point. Now what is going on in here? What is this equation? What is this equation represent? This is the equation of a line. What about this?
Line.
Line. What about this?
Line.
Line. Let's draw them. I have drawn it in my notes because MATLAB was my good friend before already. And let me draw them. And I think after drawing, we all understand what is going on. I am an awful drawer, but I try to represent exactly what is happening. This is 7.8, this is 8, 8.2, 8.4, 8.6. This is minus 8, minus 7.8, minus 7.6, minus 7.4, minus 7.2, minus 7. This is the equation x1 plus 3x2 is equal to 17, roughly. A very bad line, but this one is equation 5x1 plus 7x2 is equal to 19. And this one is equation 11x1 plus 13x2 is equal to 23. This is what's happening actually. This is what's happening actually. And we have three lines and they are not intersecting each other at one point. So that's why that we have the least S squared, still the rope part of problem has left. This is what we say that it's a least S squared problem. What we solve, it gives us the point which is like here, roughly, which means it has the minimum distance from all these 3 points. That is why that when we are substituting, we are getting an approximate answer rather than the exact values that we were supposed to get. That is why it's called overdetermined. So this is the situation that is happening with respect to our problem. Are we surprisingly happy? It was a very good wake up for Friday morning. But keep this one in your mind. Scenario like this is what is happening in the reality. We have lots of let's say planes that they supposed to have intersection and their intersection is supposed to be one line, but it is not. We will have a series of lines which are like a couple of them are intersecting in different lines. So we try to find a line in there which has this list S square, has the minimum distance from all of those lines. Or in here, we are trying to find such a point which has the minimum distance from all of these points. This is where least square problem comes in. And my drawing is pretty ugly. I recommend you in MATLAB try to plot them, if you know how to plot it, and see it, and have a feeling and observations. I mean, this is good to have an observation. I mean, like, you have to feel the topic, otherwise it's just like yet another formula. Now, we stop here and we continue on next session, but before we dismiss the class, you know that we have a presentation, a project for this course also. So it is the right time that you go and each of you go and pick up one paper recommended in line with the topic that you enjoy, you like. And the topic, the paper that you choose should show some usage of algebra in your field of research and study. For example, all of you are taking this image processing class, and I'm so sure that Pejman, when he came in astronomy in one of the classes, he talked about something called singular value decomposition for illumination enhancement. This is like a very useful application of linear algebra. That method, I mean, was proposed in 2000. I proposed it in 2008, and it was exactly when I took this course for the first time. And I got lots of citations from that work paper. So you can think of actually, I mean, while you are learning, you can think of and developing something new, or you can search in the IEEE Explorer, come up with lots of papers, pick up one which you enjoy, and then what you have to do, you have to present the paper and talk about the theorems or from mathematical point of view, algebraic point of view, how they are using algebra in order to solve that problem. You do not need to include some novelty on top of it. In other words, you can just present the paper and simulate the results. But it will be always a bonus for your future and for your grade if you can contribute on top of that paper by introducing something new on top of it. Okay? Last year we had one student who did it, and we published a paper in a journal. So I mean that is also a possibility. Do you have any question? So deadline for telling me that when is your, what is your topic, let's say, is by next Friday. You have to email me, and I have to confirm that this is an acceptable paper. Either I may not accept it because it might be very simple, or it might be very difficult, or it might be not relevant to algebra at all. But you are all wise people, probably will pick up a correct paper. Okay? You can stop.